Good evening, sir. So, this evening, I'm going to discuss my problem with solution about the perfect gas law equation. So, now, this is in module 3. So, now I'm going to read the problem in sample number 1. So, 2.5 liter container holds 0.45 moles of nitrogen gas at 315 Kelvin. So what is the pressure inside the container? So now we are going to find the volume and number of mole, and then T time temperature, and then the P is the pressure. So first we are going to find the number of volume. So volume is a liter, 2.5 liter. Then the number of mole in is a mole, number of mole is 0.45 moles. Now the temperature is Kelvin, so 315 Kelvin. So our unknown is pressure. So now we are going to find the value of pressure. So our equation or formula is PV equals nRT. So meaning to say, this P is pressure. So since we have since our pressure is unknown, so now we are going to write down here the value of volume. So our volume here is 2.5 liter, this one. Then equals our number of moles in is our mole is 0.4. This is the value of N, 0.45. Then the R is our universal constant gas is 0.08206. That is the value of R, the constant value of universal gas. So times our T, 315 Kelvin. So now to get the value of pressure, so we are going to write down here 2.5, then we are going to multiply 2.5, then divide by 2.5. So we're going to cancel this one, 25 cancel, so 11. What we are going to do here, so we are going to multiply. So 0.4, we are going to use our calculator. So 0.45 times 0.08206 times 315 equals 11.632. That is the value, that is the result. So we are going to divide this one into 2.5. So the result is 4.653 atm. So that is the value of our pressure. So this is the answer. So meaning to say, our pressure unknown here, so this is the value. So that is our problem number 1, sample number 1. So the next sample number 2 is 1.3 mole of argon gas is placed in a container at 27 Celsius at a pressure of 725 torr. What is the volume of the container in millimeter ml? So now we are going to write down here the number of mole, 1.3 mole in, then our time 300 Kelvin. So where's the 300 Kelvin? So first we are going to write down here the 300 Kelvin is the time. So to get the value of Kelvin, so first we are going to convert. So to convert this 7.25 torr, so we are going to write down here the torr, the conversion. So in 1 atmosphere is equivalent to 760 torr. So now we are going to cancel torr, the unit cancel, then we are going to multiply. So 725 torr times divide by 760. The answer is 0.95395 ATM. So now we are going to use this formula PV equals nRT. Then so our PV is 0.9, pressure 0.95395, so equals V, because our V is unknown, so we know later what is the value of V, equals 1.3 our mole. This is the value of N, and then the value of R, universal gas constant, is 0.08206. So our then times 300 Kelvin. So 300 Kelvin, that is our T. So now we are going to divide this one. Then first, before we divide, we are going to multiply this one. So 1.3, the number of mole, times the universal gas constant, 0.08206 times 300 Kelvin. So the answer is 32. So 32 divided by 0.953. So before that, we are going to cancel this one. So to get the value of our volume, so we are going to divide 32 divided by 0.95395. So the value of our volume is 33.54 liter. So that is the value of our volume. But before that, so we are going to convert liter to ml. So what we are going to do, so now we are going to convert in 33.54 liter. So we are going to convert to ml. So now in 33.54 liter, so we are going to, in 1 liter, we are going to convert. So in 1 liter is equivalent to 1000 ml. So now we are going to cancel this 1 liter, cancel, then we are going to multiply. Why we are going to multiply, not divide? Because our 1000 ml is numerator. So that's why we're going to multiply. So 33.54 liter times 1000 ml is, the answer is 33,540 ml. So that is the answer of this problem number 2, because the question here is what is the volume of the container in ml, so not in liter. So that's why we convert liter to ml. So here is the answer. So 33,540 ml. That is the answer in problem number 2. So now in problem number 3, sample number 3, how many grams of carbon dioxide, CO2, should be placed in a 250 ml container at negative 24 Celsius to produce a pressure of 95 kilopascal. So what we are going to do here is to write down here first we are going to write down the value of pressure. So 0.9378 atm atmospheric. So the V is our volume. So we are going to write down here 0.25 liter. So the next is our time. So our time is 24 Celsius, negative 24 Celsius. So our number of N is unknown. So now we are going to find the number of N. So we are going to use this equation, PV equals nRT. So now we are going to write down the number of pressure, the atmospheric pressure. So here is the number, the value 0.9378 times the number of volume 0.25 equals N. So times R, universal gas constant 0.08206, and then our temperature. So our temperature is 249. So what we are going to do here to get the value of N, so we are going to divide both sides to 20.43. So we're going to cancel this one, then we are going to divide 0.23445 divided by 20.433. So the value of our N is equal 0.011447 mole. So this is the answer of our sample number 3. But before that, we are going to first, that is not final answer. So we're going to convert. So mole. So from mole, first we are going to convert 0.01147 mole carbon dioxide. So times 44 grams over 1 mole equals 0.505 grams carbon dioxide. So this is the final answer. So how to get this 44 grams? So first we are going to get the value here. The carbon dioxide is equals to C. The value of C, the carbon is 12. So plus 2, because this one the base is 2. and then the one is 0. The oxygen here is 16, the value. So now 12 plus 2 times 16 equals 44 grams per mole. So this is the final answer of this problem number 3. So take note that ideal gas law, so PV equals nRT. So the unit of T is Kelvin, and then the unit of N is mole, and then V is L, liter, and then the P is atmospheric pressure. So this is the R, so universal gas constant. So this is the equation to get ideal gas, the equation of the ideal gas. So remember this one always. So that's all, sir, and then the next sample problem with solution is to be followed.